I'm going to do one last example of chain rule, and I'm going to combine chain rule with quotient rule. So let's say we have a problem. F of x equals x minus 2 over, let's say, x plus 5, and all of that is to the third power. All right, so number one, I know I have the chain rule. Chain rule because I have something in parentheses taken to a power. Okay, that's how you know you're doing the chain rule. So when it's time to take the derivative, derivative rules say take the exponent, bring it forward, subtract 1 from your exponent. So I'm going to do that. Bring my exponent forward. In parentheses, again, when you're doing this derivative, don't change what's inside the parentheses ever until it's time to do the chain rule part. So that's what's left, times the derivative of what's inside. All right, well, what we have inside the parentheses is a quotient. We have a fraction, a quotient. So we have to use quotient rule. Okay, by the way, side note, some of you might be tempted to say, oh, I can cancel those x's. You can't. Here, I'm going to do side note over here. Here's side note of horribleness right here. If you have this expression right here, some of you might be tempted to say, oh, I can cancel those two x's. Oh, my Lord, no. Because these are bound together by addition and subtraction. They're like handcuffs. You can't separate those terms. Okay, you can't separate them and just cancel half of them. That's like math divorce. Okay, we can't do that. So that's side note of horribleness, with sadness, crying. I don't really know what's going on. All right, so don't try to do that. But let's get back to the problem. So we were doing the chain rule. We did the derivative with our exponent, but now we have to do times the derivative of what's inside, and what's inside is a quotient. So let's remember our quotient rule. It was the derivative of the top times the bottom minus derivative of the bottom times the top over the bottom squared. All right, so that's quotient rule. That's what we're going to attack now. I have to erase the display of horribleness over here so I have room. Okay. All right. Derivative of the numerator, x minus 2. The derivative of that is just 1. Times the bottom, which is x plus 5. All right, that was easy enough. Put a big subtraction symbol and then immediately put some parentheses down so you don't miss the distributing. Derivative of the bottom, derivative of x plus 5 is 1. Times the top, which is x minus 2. All right, over the bottom squared, x plus 5 squared. Okay, so all of that is just the derivative of what's inside. Okay, but again, because what was inside is a quotient, we had to do the quotient rule. So now we need to do some cleanup. So we have 3 times x minus 2 over x plus 5, all to the second power. Over here going on, well, technically you're distributing that 1, but that just gives you x plus 5. Over here, you're distributing a negative 1, which gives you negative x plus 2 in the numerator. And that's squared. So cleanup's almost done. F prime of x or dy dx. But since it gave us in f of x format, we should put x prime. 3 times x minus 2 over x plus 5 squared. Times, now here the x's are going to cancel. X minus x, no more x's. And then I have 5 plus 2, which is 7 over x plus 5. But this one, just the denominator is squared. All right, technically you can combine these, okay? So be careful here. First of all, be careful here. This one, the second one, only the denominator is squared. On this one, both the numerator and denominator is squared. Okay, but if you're squaring a fraction, you're multiplying that fraction times itself. So what that really means is you're multiplying the numerator times itself. Well, that's x minus 2 squared over the denominator times itself. So see how I've separated it? You can do that because that's what it means. Multiplying a fraction by itself means doing the numerator by itself over the denominator by itself. okay, times, and then I have 7 times x plus 5 squared. Why did I do that? Well, the advantage is the way that problem sat right there, I could not multiply this 7 times the x minus 2. I couldn't do it. Well, I still can't do it there. And the reason you can't do it is because you have this whole expression with a squared. Okay? On this one, though, you can multiply these two together. All right, doorbell just rang. I don't know where I am. Oh, yeah. Okay, so here's what it allows me to do. I can simplify a little bit more because I've done that. If you're confused right now, stop the video, rewind it a few steps, and listen to the explanation again. If you're getting overwhelmed and freaked out, stop the video, back it up. You can watch it 3 or 4 times if you need to. Okay, cleanup. Let's look at the cleanup. I have the number 3 times this times this. So, and remember, the number 3 is really like 3 over 1. That's what whole number 3 is. Okay, so here's what I could do. The 3 times the 7. That's 21. And then I got this parentheses here. I cannot distribute inside those parentheses. And then I have x plus 5 squared times another x plus 5 squared. That means I have x plus 5 to the 4th. You have 4 of them. Okay, so that would be simplest form for your answer. This is how I would want the answer. Now, does that mean that this in red is wrong? No, it's just unsimplified. I mean, look at the red and look at the green. The green is a whole lot simpler, and that's what your goal is. Just be really careful how you do it. You've got to really know your algebra backwards and forwards. So be careful with what you can combine. The way this was written up above, you could not combine it. We had to rewrite it. I can't just take this, x plus 5, and multiply it by this the way it is, because that x plus 5 is trapped in this giant parentheses. But once I separated the numerator and denominator, then I was able to do that. Okay, so you kind of got to watch the different rules. But that's that example.